Now let us solve one numerical which is based on diffraction. Here the problem statement is, considering the limitations imposed by diffraction, calculate the greatest distance L at which human eye can distinguish two headlights of an automobile car. Given the distance between headlights is 1.20 meter and lambda equals to 5890. Right, so this is our problem. What we need to determine is greatest distance L through which human eye can distinguish between two headlights of a given car. So for this particular problem, we know that Rayleigh criteria will be the one which will help us to determine this solution, right? So let us take the statement of Rayleigh criteria. So according to it, sin alpha equals to 1.22 lambda by d, right? So this is Rayleigh criteria, and we also know that sin alpha is equals to distance between two headlights divided by distance between car and eye. That means distance between the objects which we need to distinguish and the distance between source and the eye, right? So this is sin alpha value. So we can simply equate these two equations. So what we can get is 1.22 lambda by d is equals to distance between headlight upon distance between car and eye, right? So this is nothing but L equals to d into d upon 1.22 lambda. This capital D is distance between the object which you need to distinguish. So it is 1.2 meter, right? We need to convert it into centimeter. So what we are going to do is, we will here use 1.2 into 100, so that 1.2 meter is getting converted into centimeter into 0.5. So what is 0.5 here? 0.5 is small d. What is small d? Small d is basically distance between our eye, human eye, and it is usually taken as 0.5 centimeter, right? It is usually taken as 0.5. So we have simply put 0.5 here. Now small d is basically diameter of pupil of eye, usually which is taken as 0.5. Now 1.2 into 100 into 0.5, right, divided by 1.22 into lambda. So lambda value is 5890, right? So we need to convert it. So it will be 1.22 into lambda, which is 5890 into 10 raised to minus 8. Once you solve it, you will get answer as 8.35 into 10 raised to power 5 centimeter. Converted into kilometer, it will be 8.35 kilometer, right? So this is our answer for the given problem. Now let us move ahead with next topic, which is pyrometer. So what do we understand by the word pyrometer? Pyrometer is basically a device which is used to measure a temperature of very hot body, where thermometer cannot brought into contact, or whenever we want to measure temperature of a hot moving body, we opt for pyrometer. There are two types of pyrometer, radiation pyrometer and optical pyrometer. So let us see them one by one. Radiation pyrometer. So what do we understand by the word radiation pyrometer? It works on the principle of radiation, as the word itself suggests. With the help of radiation, it will help us to determine the temperature of that particular body. So radiation pyrometer is first one. It works on how the radiation is being emitted by the hot body. And here you can see electromagnetic spectrum. So optical pyrometer is used for this particular range, and then for bodies which are giving radiation, you can use radiation pyrometer, and for other you can use different kind of various thermometers, right? Now here it is based on the wavelength and temperature distribution. So let us discuss what is basically the principle of radiation pyrometer. It works on the principle of Stephen-Boltzmann law. We all are very much aware about Stephen-Boltzmann law. It states that intensity of radiant energy which is emitted by hot body varies as fourth power of the absolute temperature. Right, so according to Stephen-Boltzmann law, radiant energy or radiation given by any hot body varies with fourth power of absolute temperature. And in radiation pyrometer, the visible and IR infrared energy is focused on radiation detector, which converts them into proportional electrical signal, and that will ultimately give us our targeted temperature. Now, as temperature of emitting source changes, color will be changed. That is, for low temperature the color will be dull, and for higher temperature the color will be more brighter, right? So from lower to higher, color will be varied between red to white. Now for practical radiating bodies, we have to consider adsorption, reflectivity, transmissibility and emissivity. And in some cases we need to use all four of them to detect our desired temperature. So we must understand this first, that how many of them we need to consider for our equipment, right? So we can use absorption, reflectivity, transmissibility and emissivity. Now here you can see a pictorial diagram of a radiation pyrometer. There is a hot body, as you can see. This will emit the radiation, or this is the body whose temperature we need to detect. So it will emit the radiation. There is one lens which is placed on radiation pyrometer. This lens is directed towards the body so that all the radiation which is coming out of that particular body will fall on this lens. Once that radiation fall on the lens, it will then converge to one point, right? It will then converge. The lens will help to converge all the falling radiation to one point, which is known as thermopile. This is a thermopile. And due to this thermopile, there will be a signal given which will help us to determine the temperature. Here also you can see this is our target, this is our lens, and this is a diaphragm where you are focusing all your energies or the radiation, and then with the help of current we can detect the temperature. Now coming to what is advantages of using radiation pyrometer. So radiation pyrometer has biggest advantage that it has ability to measure very high temperature, right? It can measure a very high temperature. Second advantage is there is no need for direct contact with the source. Third is it is having a fast response, right? So the response speed is very high. Then there is a high output. High output means the accuracy or precision is very high, and the cost is also minimum. So these are few advantages of radiation pyrometer. Now coming to disadvantages part, it is having a non-linear scale. This is the biggest disadvantage which we are facing, that it is having a non-linear scale. Error may occur due to absorbing media, right? Emissivity of target will affect measurement, more costlier than fragile thermocouple and RTD. RTD and thermocouples are very cheap as compared to this radiation pyrometer, and it also requires relatively wide temperature span so that it can easily detect it, and error due to interleaving media is also present in our radiation pyrometer. Now let us discuss the application of this particular pyrometer. So it can be used where life of thermocouple limits, that is corrosive environment. Whenever there is corrosive environment, we can easily use radiation pyrometer. For any kind of corrosive equipment, corrosive reactors, corrosive fluid, we can easily use radiation pyrometer because there is no direct contact, so there is no way it can harm our pyrometer. Second is measuring temperature of moving element, right? We use this for measuring the temperature of hot moving objects. Then we also use for measuring temperature of not easily accessible targets. If there is an equipment which is out of our reach, or a place where it is quite difficult or risky to reach there and detect the temperature. So in all such cases, we use radiation pyrometer. And lastly, for measuring average temperature of large surface area. If our targeted area, or if our targeted source is having a huge area, it is not possible to go and detect each and every portion of that particular body to find the temperature. So in that case, we go for an average temperature which can be determined by radiation pyrometer. Now let us see the next one, which is our optical pyrometer. The word optical itself suggests it has to do with optics, right? So let us see what is principle of optical pyrometer. The spectral radiant intensity of radiated energy from heated body at a given wavelength is proportional to temperature of the body. So this is the basic principle which is followed by optical pyrometer. That is, temperature of hot body can be measured in terms of spectral radiant intensity at certain wavelength. So optical pyrometer basically operates in visible spectrum range, which is around 0.65 micron. So here you can see a pictorial diagram of an optical pyrometer. It contains an eye lens, there is one red filter and absorption screen. We also have one reference temperature lamp, as you can see here, and it will help us to detect the temperature of our source. Right, there is a lens which is objective lens and a temperature source. Now the filament lamp which we are using will act as a standard source, and whatever energy we are using or whatever target we need to determine the temperature will compared with this particular filament lamp, right? So this is our standard source which is placed exactly at the focus of object, so that image of hot target can be focused on plane of filament, and due to this target image and filament lamp appear superimposed on another when viewed through the eyepiece. A 2 voltage battery along with millimeter and rheostat is also attached, so that whatever temperature has been detected will be transferred in the form of current, and it is given in the form of temperature which we need to determine, right? So the temperature range is limited here, which is around 760 degrees centigrade on low end, because there is insufficient emission of visible light below 760 degrees centigrade, right? So we need to make sure that we use optical pyrometer within the given range. Now let us see advantages and limitations or disadvantages of optical pyrometer. The first advantage of optical pyrometer is that it is lightweight and portable, right? It is having a very light weight and it is compact, so it is very portable to carry. And the second and foremost important advantage of using optical pyrometer is its accuracy. It is very good and accurate in giving the results. Talking about disadvantages or limitations of optical pyrometer is that it can't be used for measuring clean burning fuel, as they do not have radiant energy in the visible range. So we cannot use optical pyrometer for clean burning fuels. And second is, its working depend on correct matching of intensities of target and the lamp, filament lamp which we are using, right? So this is somewhat tricky in some cases where the match is not the nearby. So in that case we might get some misleading results. So this is all about pyrometers and numericals. I hope all the topics which we have covered today is clear. Thank you.